Hello. So, as this probability and statistics series is coming to a close, the last thing we'll look at is exploratory data analysis, and that is basically learning the data, understanding the data, preparing the data, so it'll be ready for statistical testing, modeling, machine learning, and all of those things. So we will be looking at airline customer satisfaction data. This data was gathered from Kaggle. And the first thing in exploratory data analysis is understanding the structure and shape of the data and cleaning that data. So as we start out looking at this, we will have 129,880 records and 23 columns. And once we check for nulls and empty blanks and things and duplicates, once we check for those, remove those or replace them, it changes the data, and we actually end up with 129,487 records and 23 columns. So we check again to make sure and to see our data types and look at our fields. So here we see that it has actually decreased some. We check to ensure that we do not have any missing values remaining. So there are no missing values. We just take a look at the data because, again, we're exploring the data. We want to get to know and understand the data. So we're looking at the fields, looking at which one can be categorical, which ones are numerical, even if there's going to be some fields that need to be created later. So since we will be looking at satisfaction, and satisfaction is a string, I will be creating a binary variable for that, so zeros and ones. I will also do delay, but I won't necessarily use delay, but just in case down the line I decide to use delay as an indicator, it has its own binary column created. So you will see that here where we create delays, making those ones and zeros, and same for satisfaction, we make those binary as well. And as you can see here on the end, those columns have been added, and our new shape is actually 25 columns instead of 23 columns. So we save that data set, and again, we are exploring. So we look into the descriptive statistics of the data set, looking at the means and how everything is distributed, and just some of those high-level descriptive statistics. We're looking for patterns. So if something jumps out at you, if the mean and median are drastically different, things like that, we know they're outliers, or there may be some skewed data sets. So that's why we're looking at the descriptive statistics now. As we continue, because there are so many variables, I categorize them. So I have service features, which includes in-flight Wi-Fi services, food and drink, seat comfort, cleanliness. I will add more to this category as we continue, but we also want to just see some visualizations so that we can see some of those things that may not have jumped out at us from those descriptive statistics. So looking at satisfaction by in-flight Wi-Fi, satisfied, roughly 20,000 people were satisfied, giving it a 4 out of 5. Just around 18,000 satisfied, giving it a 5. So we can see that in-flight Wi-Fi service customers are satisfied with that area. Food and drink is kind of tied between satisfied and dissatisfied, and that is pretty interesting to see. Also, seat comfort Pretty level here around the threes and the fours between satisfied and dissatisfied. And cleanliness, satisfied is really high in the 4 and 5 levels of customers that are satisfied. So cleanliness has very high satisfaction ratings. I also grouped by convenience. So online support, online booking, gate location, leg room, bag handling, all of those things that make it easier or should make it easier for the customer. So I grouped it by convenience as well. See very high satisfactions with online support, very high satisfaction ratings with online booking. The color switch, so just be mindful of that. But blue is now satisfied on this one, and it's pretty level between satisfied and dissatisfied on the fours, but the threes, there are more dissatisfied customers as we look at the threes, so more neutral. And back to the orange is satisfied is onboard servicing has a high satisfaction rating as well. And as we continue, those are the type of things that exploratory data analysis is supposed to do. It's supposed to make it more easy to see some of those patterns and anomalies along the way. So looking at the correlation, I did a Pearson correlation and it's a little small, not it's much smaller than I expected, but we can see here that there's a higher correlation between food and drink, and pretty sure that is seat comfort. They're a little off alignment, but I'm pretty sure that's seat comfort. As well as here, we have online boarding, and I'm pretty sure that is online support. And if we're looking at satisfaction, the binary that we created, the highest correlation, I'll go up, between binary, the satisfaction binary score is with in-flight entertainment. So now that we have looked at the data, we've cleaned the data, we have made the variables that we need, we can start our hypothesis testing. And so our research question that we will be answering is, did satisfied and dissatisfied passengers give different ratings to a service feature, such as in-flight Wi-Fi service? The null hypothesis is there is no difference in the median ratings between the groups, and the alternative hypothesis is there is a significant difference in median ratings between the groups. So before we get into the test, we must address the assumptions of multicollinearity, normality, and homoscedasticity. So we complete those tests, and I'll jump down to the results. So the multicollinearity check, we use the variance indicator or the factor. And if they are between 5 and 10, then that indicates multicollinearity. But as you can see, the variables are all less than 5. So there is no multicollinearity. If they were, we may would have to remove a couple of these because they would be so highly correlated that they would be obsolete. Also checking for normality, we have the Shapiro-Wilks test here, and the p-value is less than 0.05, so the residuals do not follow normal distribution. And checking for homoscedasticity, looking at the p-value again, it is less than 0.05, so heteroscedasticity or unequal variance is present. So because of the non-normal distribution and heteroscedasticity, we will use a non-parametric test. So we'll be using the Kruskal-Wallis test because there are 3 or more variables as well. And afterwards, we'll combine that with the Tukey's post hoc test to identify which groups differ, if that is the case. And so again, we have those service features. I added in some more as I stated that I would. And we did the Kruskal-Wallis test. And so it does it for each feature. So we can see the p-values are all less than 0.05. So that means we must reject the null hypothesis. There is a significant difference in each of these features between the satisfied and dissatisfied passengers. Even looking at the two Tuckies, the p-values are also less than 0.05, and this is for each feature, as you can see. So we are rejecting that null hypothesis because there is a difference in median. And it seems as though because Tuckies are all less than, that they all actually have a difference. Again, this is much smaller than I thought. I do apologize. That works. So just looking at the box plots of each of these features, comparing satisfied and dissatisfied um, passenger scores. So you can just visualize the difference in medians and see that there is actually difference, and it supports the test results as well. Lastly, a regression model. Again, we're using those in-flight features or service features as well as satisfaction binary to fit a model. So we use the weighted least squares because this is non-parametric, and it has mainly because it's heteroscedastic. So given this R value is 1, it means that it can be a predictive model. And as we look at these scores here, as you can see the coefficients here. So the coefficients are non-zero, so the model has predictive power, and based on the coefficient, most of the ratings and features increase as satisfaction will be positively increased as well. Food and drinks had a negative coefficient here. So if it declines, that will also decline the satisfaction ratings. And I did complete a report for exploratory data analysis, just given the process, the introduction of what we're doing, what the data is comprised of, how the data exploration is going, some descriptive statistics and what we're looking at. And basically, this is part of the data exploration, some visualizations and the predictions using those hypothesis tests, and given the testing that we did for the assumptions, given some more visualizations and um, the results of the linear regression model. I hope you enjoyed.